Hello, I'm Robert, founder of Doomsday Debunked. I'm just going to explain a little bit about my non-techy interface to the NASA Sentry table. And if you look at the techy numbers, then they're really hard for most people to understand. I mean, what does all that mean if you're not got some background in maths at least? But the only thing that matters really is this bit at the end called the Torino scale and the zero. That's all that you need to read in this table. And if you go back here and you click on Torino scale, then 0 means no hazard. 1 means normal, and that will happen maybe once or twice a year, that you get an asteroid that briefly reaches normal. Sometimes it gets all the way up to meriting attention by astronomers. That's only happened, I think, with Apophis, and that went right up to 4. Still, it's not a warning, so NASA has never issued anything that would count as a warning to the general public, despite there being news stories about Apophis, but it never reached 5, which was the first stage at which it would be considering to be of some concern to the public. It's never got there. But sometime, next century or so, something is going to end up there. And then but likely a very small, tiny object, maybe going to fall into the Pacific or something like that. So that hasn't happened yet. So anyway, you look there, and that's what 0 means. So we go back up. If we go back to the top of the page, and it says 0, no hazard, no asteroid or comet warnings. They all are harmless to Earth, and that's because you go there and they're all zeros. That's all that's saying. And it's sorted normally with the highest hazard first, which is 0. So in other words, it's no hazard. So that's all. Basically that's all you need to do. You don't need to go any further. Just go to this page, look there, and that just reassures you. But you would know anyway, because it would be on the mainstream news. If there was any asteroid that you needed to know about, then you just need to turn on your TV and everyone would be talking about it. But anyway, if you want to check a little bit further, then you've come across something like this. This is the New York Post. It's usually the Daily Express, sometimes it's Metro magazine, sometimes it's New York Post, sometimes it's the Sun or the Daily Star or something. And you see something like this: Asteroid terror, NASA spot mammoth space rock to hit Earth's orbit 5 days before Christmas. And that's rather strange, actually. Hit Earth's orbit. How can you hit an orbit? It doesn't make sense. The orbit is the path that Earth travels around the Sun. These are people whoever wrote this didn't have a very good grasp of science and astronomy. And anyway, this is the name of the asteroid, and what you need to look at is the number, which is the year on which it was discovered, and then WH1, which is it tells you where it was found, when it was found in the year, and also some extra letter and number in order to so that each individual asteroid found that year has got this designation, which is completely unique. So then you just copy that, go over here, and you click to search for object, and you do right click and paste, except I've obviously already done it. So there we are, and you click search, and well, it's just doing it again, and it says it was not found in the Sentry database or as a removed object. Have you entered its name correctly? Well, surely we have. If it's a year and then a couple of letters and then a 1, and especially if you've done copy paste, that is the correct thing. So we've gone far enough. It was never in. If it's not in the Sentry database and it's not a removed object, and we entered the name correctly, then as it says there, if this is its correct name, it is harmless. It means it isn't in the database and never was in it. It could have been in it before the database was first constructed and then removed before they actually made this database. It could have been an object they were tracking long ago, but most often it just never was in it. And this just was never in it. Never was a concern. And so now, so we've gone far enough. Now you know this is a harmless object. But if you want to find out more, then you can click here. So first of all, you go to the page at ESA, because they're quite informative if it's there. I will show you one in a minute that it's there, but this one, object not found. If you clicked all asteroids, would that help? Theirs isn't very. Oh, and then we put the thing in there. We've got it. Right click and paste, and then search and see if it's got it. But I mean, often ESA doesn't have it, so you don't feel that. Don't be surprised if it's not there. Seems it has got it. So there we go. Unfortunately, I can't automatically search all the ESA asteroids from this page. I can't figure out how to get to this page from that one. But let's somehow figure it out. You've got to get that number at the beginning right, I think. Anyway, there it is. And so now if you go and look at it, and it says object is not in risk list and object is not in priority list. It's not in the risk list. It never was a risk, and it isn't in the risk. So that really helps to confirm that this object is completely harmless, because you've got that is obviously the same one. ESA leave out the space between the year and the letters. So there we are. It's a completely harmless object. And then the rest of this is just if you want to find out more about it. So for instance, you can click on the orbit diagram, and that shows its current orbit, but it's not very good for going into the future. This is just gives a rough idea. It shows its orbit just now, because the orbit keeps changing every time it flies past something. But that is completely taken account of in all the predictions. And when they say it's safe, then they use much more sophisticated methods than that orbit diagram to figure it out. They use a proper gravitation simulation of all the planets in the solar system, and I think about a dozen largest asteroids or something. Most of the large asteroids are also included in that database as well, and then they take account of all their gravity and to figure it out. And so if you want, you can also click here, and that shows the observations, and this is how they know about it. If it's there, it's usually there. So these are all the observations. You can see going back to 2006, which when it was discovered, and these all. So as people talk about them doing this all being secret, it's not. Everything is in public. If you understand astronomy, then you can read these observations, and it's quite techy, but it says the right ascension, the declination, the magnitude. So this is the position in the sky. This is the date of the observation. This is the observatory that found it. This is the reference of the minor. I think that's a report that is mentioned in. I'm not sure. Oh no, is that? No, that's not the name of the report. That's just got its designation. And then this is who observed it. So that's the Stewart Observatory. That was Catalina Sky Survey. This is the OAM Observatory, and so on. These are the people who've been observing it. And you see, it's totally public, in the open. Anyone can go and look at this. And then you've got the magnitude, which is how bright it was. The smaller that number is, the brighter it is. And you can also, then using those observations, you can then work out an orbit from it. So the other people are very good at working out orbits, but the Center for Near Earth Object Studies is the very best of all in the US. But there is also the Minor Planet Center. They also work out orbits, taking account of the gravity of all the planets and the moon and the larger asteroids. So that's that. And you see, there's no way it can't be hidden. As soon as someone makes a new observation, then it'll pop at the end there. Look, there we are. Observation was found 2019 on 23rd of October, and that was by the Mount Lemons survey, and there it is. For anyone in the world can go there and read it. And if you're really keen, you can go and look at the circulars which are many times a day, I think, and about all the latest observations. So yeah, you can search the recent minor planet circulars, and you might find a few. So there we are. That's 6. No, that doesn't always work. 2000. No, it's not there. Anyway, the observation page is the better one. And sometimes that comes up with stuff. That's the orbit diagram. That's got some details about it. That's the orbit diagram, which shows where its orbit is, but this is only for this. As it says, this orbit view was implemented using two-body methods, and it shouldn't be used for long-term trajectories over years or decades or planetary encounters. So if it comes close to a planet, or if it's or years into the future, but you can do it for it's reasonably accurate for days into the future. So you can go and use this count and see where it is. That's where it is now. This particular asteroid. That's where it is just now. And actually, where was the that asteroid terror thing? It said something about it being its closest approach on December 20, just days before Christmas, and it's currently thought to be. It's known to be. It's not thought to be. And it could be further influenced by the Yarkovsky effect. It's a tiny, tiny nudge. It's not going to make any noticeable difference to something. It's only relevant if it does very, very close flybys of Earth and it gets very close to Earth, and then over either a decade or a very close flyby where it's very sensitive, then that might be some relevance. But that's all included in all the calculations. So, so then, if you go and look at this, they're talking about the 20th of December. If we go to the orbit, then where was it? The orbit. Then we can go to the calendar. I tend to forget where it is. There's the calendar, and we can go to November, December. Go to the 20th, and I think it's already done it. And there it is, and it is indeed very close to Earth, but you can see it's quite a bit away. That's its closest point. See, you can even see now. If you find that a bit alarming, don't worry. This is very very high, very, very low resolution. I mean, that's the distance to the sun. That's actually a vast distance apart there, and it's completely harmless. And then you can also go to additional information, and that shows that the closest it gets to Earth's orbit is 2.35% of the distance to the Sun. You can actually find that in kilometers. That's a long distance. If you just click on right click and copy, go over here, and you right click and paste, and then you add in kilometers, or you could say in miles if you like, if you want to put it in miles, and click that, and it shows. And this is just Google converting AU into kilometers. Remember to have the decimal point at the start of your thing to copy over, and it'll tell you that it is 3.3. I've just succeeded in threes. You've got 693,519. So it's 3,519,693 kilometers away. 3.5 million kilometers away, and that's the closest that it gets to Earth's orbit. That's not the distance away from Earth, that's the closest it gets to our orbit. And some things get close to our orbit but never get anywhere near us. It's not the same thing. But this one actually gets kind of fairly close to us, but still, that's more than 10 times the distance to the Moon. It's very far away. So there's lots of other techie detail that you can find out there, but really, it's only academic information. And so the useful thing about this is my programming here. So when you click search for object, put your thing in, and this is first of all searching it searches the sentry table. It doesn't find it in the sentry table. It then looks to see if it's a removed object. If it was found as a removed object, it would tell you the date that it was removed from the table. It didn't find that either, and so then it gives all these links. It automatically generates a link to the page at ESA and another couple of places. It's JPL, the orbit diagram, and it gives you a search in Wikipedia, which sometimes for well-known things it's worth doing. But no, it doesn't have that. It doesn't usually. Just include it in case. So that's it. And if you put a sort of well-known thing, like you type in maybe, oh sorry, what am I doing? I've got my fingers in the wrong place on the keyboard. I type in Apophis. Wait for it to do its thing. And Apophis, then I've done this page, so it'll find you the debunk. So if I've already done a debunk about the asteroid, then you can click on there and find the debunk. So it's got all that combined together in there. And then for one that actually is like this, then you have quite a few other things that you can do down here. If it's an actual genuine asteroid, then that actually is a potential impact, including looking at the impact effects and looking at the possible tsunami and stuff like that. Which, but you don't need to worry. If you click through to that link, there's no need to be scared of Apophis, because it flies. Its orbit is very well known, and it flies past very accurately in 2029. If you click through to that page, and it all explains there, so you don't need to worry. You see, it's going to be at that distance from the Earth, exactly within that region. So quite a long way inside of geostationary, but a long way from Earth. And this is a better look at it. If you look at it, that's the orbit, and this is geostationary orbit, where all the satellites are, the geostationary satellites. And so, although it's coming inside of it, it's in an orbit that sort of goes past it and around it at an angle. So they know that very well. Now, because it's going so close, then a very slight move of even 100 meters there, you see it's actually bent slightly by Earth's gravity as it goes past. And if you move it just a very slightly bit more, it won't be bent so much. If slightly this way, it's bent more. So when an asteroid comes very close to the Earth like that, then that's called a keyhole. Because if you continue that orbit on and on and on, maybe eventually it can hit Earth. So there's a chance of Apophis hitting Earth in 2060. And we don't know, because it's very sensitive. Even if it was just 50 meters one way or 50 meters another, that could make all the difference. Especially 100 meters, it could make all the difference to where it will be in 2060. And we just don't know its orbit to that degree of accuracy. So when they talk about a keyhole, that's what they mean. It's a little region there that has to pass through very exactly if it's going to hit Earth in the far future. Now, you don't need to worry about Apophis. First of all, it's quite a small one. It's not big enough to, for instance, do anything, to have enough dust in the atmosphere to cool down the Earth or anything. And then the other thing is that it's very, very easy to deflect, because it does these frequent flybys of Earth, because it's such a long time. So so for instance, we might actually send a spacecraft to go and look at it in 2029. It comes so close this time that it's actually going to be affected tidally, and maybe little rocks will start moving on the surface, because it's the tidal effects of Earth, just like the tides of Earth. As it spins, then the tides, it will actually rise tides. It's likely to be a loose pile of rubbles which will move around due to the tidal effect of Earth as it spins, just like the tides on Earth. Of oceans, you have tides of rocks on asteroids, if they're very small, if they could pass very close to Earth. So there's a lot of interest in actually trying to land a little spacecraft on this in 2029 and see if you can actually spot things happening, things changing on its surface as it moves past, maybe jiggles a little bit. But if you were to put, I think it's reflective layer 225 meters by 225 meters on its surface, that would be enough to change it in a decade into the future by about 30 Earth radii, I think they said. So that's enough to be very certain that you want to be careful if you shift its orbit, that you are not going to change a miss into a hit. But if you think that it's got a decent chance of hitting a decade from now, put basically a space blanket, a reflective blanket on it of 225 meters. That's quite big, but that's some of you might want that in feet. But you know how long 100 meters is, like how long Usain Bolt. He runs 100 meters, twice that and another 25 meters. Then if you could have a little bit of reflective material about twice the length that Usain Bolt runs in the Olympics and a little bit more, and that square, put a material like that, thin layer of material on top of this asteroid, which you could fold it all up and then spread it out when you get there, like a solar sail, then that is enough to change its orbit just by the changing the way that the surface heats up. And that is the Yarkovsky effect. That is to do with, that they were talking about in that article, as it spins, then it's heated up on the sunny side, and then as the sunny side spins around towards the dark side, then it radiates heat away. And just the heat itself has a very, very slight pressure just through the photons of the heat being radiated out into space, and that shifts it very, very, very slightly. And then if you put a space blanket like this exactly in the right place, then you change the way that the heat is reflected from it. And that's enough to change the amount of heat that is radiated away from it on the night side. And that's enough to shift it by 30 Earth diameters about a decade into the future. So this asteroid is very easy to deflect. You don't even, not nuclear bombs, not even firing rockets at it, just put a thin sheet of reflective material on it. Or you could try painting part of it white with a kind of white dust. So that's why we could do that already. And now think about what technology we'll have in 2060 in rocket technology. I mean, you just don't need to worry about Apophis at all. So that's it. That's Apophis, which some of you were worried about, and I think I've done everything now. So that's how you do it. So I'll just do it very quickly through it again. Go to tracked, and it says no asteroid or comet warnings. That really is all you need to do. Just go to that page, look at it. If it says that, then that shows that this story is just sensationalist nonsense, which it is, by someone who doesn't, as you say, hit Earth's orbit. Doesn't make any sense. I mean, you get these people who they're not science writers. They're just ordinary hack journalists who write sensationalist stuff. And sadly it appears in Google News when it shouldn't really. And then if you want to find out more, you go to search for object, you copy and paste it in there. I wonder if that one is still in if I do a paste. No, that was that, of course. Yes, so you copy and paste this wherever it's gone. So you just copy and paste that over there. So once you know what to do, it's very easy. And then wait for it to find its thing. It says not found in the sentry database or as a removed object. Have you entered this name correctly? And if you're pretty sure you have, then you know it's harmless. And it wasn't in the database, never was in it. And then if you find out more, you go to the page ADISA, and then at the page ADISA you might have to enter the name again and do that search like I did for all asteroids. And if it's not there, then you can go there just to check. You can click there just to check that you've got the name right. But this is all, you don't really need to do any of that. But you didn't need to do any of that at all. You didn't need to search for the object. But that is basically the process, if you want to find out more. And so I hope that helps.